practice so it doesn't take this long, because once you write A, B, C, and you have A, which is 85, you have A, which is 14, and you have B, which is 7, all you have to write is sine 85 degrees over 14 equals sine B over 7. So then sine B equals 7 times sine 85 degrees over 14. So then with a graphing calculator, where are you guys? Okay. I have 7 multiplied by sine 85 and divide by 14. And I have the answer. I go to arcsine right away, right there. I don't type in anything. And I get 29.87. So B is 29.87 degrees. If B is 29.87 degrees, then from 180, I subtract 29.87 and also subtract 85. And I got the third angle, which is 63.13. And then the only thing that I need to determine is C. So I will write here that sine 63.13 degrees divided by C. And therefore, I have that C. I already wrote this. I shouldn't have, but I did. So then in order to determine C, I have C times sine. So C equals 14 times sine 63.13. Everything divided by sine 85 degrees. And that's my C, and I'm done. I hope you're going to practice so it doesn't take this long, because I think it should not. So 63.13.
It's 65.13. Isn't it?
You may be right. Yes, thank you. 65. 65. Thank you. 65. Good. So then I have 14. Good catch. Thank you. Sine 65.13 and divide by sine 85, and that's it. So it's 12.75. Okay. Good. So finally we get to chapter 9. In chapter 9, we're going to talk about something called conic sections. And the answer, or if you ask the question why, because of applications. They have a lot of applications in real life situations. And we have 4 conic sections. We already discussed the circle before. So let me just remind you, refresh your memory on the equation of the circle. So circle, x minus h everything squared plus y minus k everything squared equals r squared, where these are the coordinates of the center and this is the radius. Not the squared, just r is the radius. So this was done a long time ago. Now we're going to look at parabola as our next step. You can say parabola, but we've discussed parabolas, yes. However, there are several situations for parabola. Actually 4. So the original ones that we talked about, either opening upward or downward. But also we're going to discuss this situation, which is not a function, opening to the right, or this situation, which is not a function, opening to the left. In all these 4 situations, we are going to look at details that we have never looked before. Okay. So, parabola. A slightly different definition than the one we looked at before. So here it is. We're going to look, let me just clarify. We're going to look at two different steps. Step 1, centered all of them at the origin. And step 2, slightly more difficult, more complicated, not centered at the origin. So we are going to first look at the easy situation in which, for the parabola, in which it is centered at the origin. And then we're going to address the other option when it's not centered at the origin. Then we move on to the ellipse. And we're going to look at the ellipse that is centered at the origin, and then it's not. And then we look at the hyperbola, centered at the origin, and then not. So we start with the easy situation in all three cases. Okay. So here is a parabola centered at the origin. And as I mentioned, we're looking at different aspect. This is still the vertex. So the vertex has not changed. But also the parabola has a focus. We've never discussed the focus of a parabola. So it's, in this case, if the parabola is opening up and the vertex is at the origin, as I mentioned, centered at the origin, and this is the axis of symmetry. The focus is somewhere here. On the axis of symmetry is denoted by F, for standing for focus. And it has coordinates in such a way that any point, so I'm going to draw, so this distance, we're going to call it A, lowercase a. The same distance on the other side of the parabola, this is also A. It's a distance from the vertex to the focus, and the distance from the vertex to this line, called directrix, are equal. So this is A and this is A as well. Now, what is it so special, and why are we looking like this at this parabola? Well, any point on the parabola has equal distance between itself and the focus, and itself and the directrix. In my picture, it's not 100%. It appears that this is smaller than this, but these have to be the same. So in other words, another definition for the parabola is this. Any point on the parabola is equidistant, meaning it is at the same distance away from the focus and away from the directrix. Let's say this point. This point is at the same distance. This distance is equal to this distance. I'm going to use 3 bars because there are different distances. Or I better use another color. So this point here is found at the same distance from the focus, and my graph is not perfect, and the same distance from the directrix. Where, as an example, where is this used? In satellite dish, for example. That's where the convert is, right here in the middle, in the focus. Now, of course, we have the same situation if the parabola is looks like any other forms. We just looked at one that looks like this, but let's look at one of these two. Exactly the same idea. And I'm going to stick with the origin, centered at the origin. So this is a parabola. It's not a function. It has the focus, let's say here. This distance is A. This distance is A. So this time, the directrix of the parabola is a vertical line. This one was y equals negative A. This one is x equals negative A. Any point on this parabola is found at the same distance from the focus as well as from the directrix. They have to be the same. Again, they don't appear to be the same, so I should have opened it up more, but they have to be the same. Okay, let's take a look at the handout. I think I have it right here. Where's my handout? Okay, so here is a table with all those 4 possibilities that I showed you, and we're talking about the basic situation in which the vertex is the origin, at the origin. Because we have this one, which is a more sophisticated situation. As you see, the vertex is no longer at the origin. But let's take it easy, slowly. So we are looking at these situations. We have, let's start with few examples. Find the vertex, the focus, the directrix of the parabola, and graph the equation. This one is y squared equals 8x. Let's take a look. Y squared equals 8x. The next one is a different story. It's x squared equals negative 4y. X squared equals negative 4y. And we have to determine different things, which basically this distance from the vertex and the focus. That's the A that we are looking for. Okay. Okay. So let's start with this one. Or other examples. If you'd like to pick other examples from the book, I can open the book. Okay, let me move on to page 8. Okay, so let's start with y squared equals 8x. We want to find the vertex. It has to be 0, 0. When x is 0, y is 0. So, because that's what we are discussing right now. We're discussing the situation in which the vertex is at the origin. Okay, then they want us to find the focus, which is an ordered pair, a point, and the directrix. And then graph the equation. So we have y squared equals 8x. Again, we look at the table. Y squared equals 8x is the situation. The axis of symmetry is the x-axis, of course, and it opens to the right. Y squared equals 8x. So the formula is y squared equals 4ax. By comparison, of course, 8 has to equal 4a, which means a equals 2. What does this mean? Okay. Here's the vertex. Here is 2, 0, 2, 0, which is the focus. Vertex, focus, 2, 0. And now, when x is 2, this is not the directrix. The directrix is right here. Let's graph it already. So the directrix is x equals negative 2. How come? Because this distance is a, and this distance has to be also a. If this is 2 units, this has to be 2 units. This is the vertex. The vertex is here. This is 2 units. This has to be 2 units. Okay. And now I have to graph the parabola, but I don't know how much is, I mean, how wide it is or how narrow it is. I need to determine 2 more points. Okay. So knowing that x is 2, when I replace x by 2 to determine 2 points on this line, which is not part of the graph, but I want to determine these 2 points, one here and one here, when x is 2. No problem. It means that y squared equals 16. When I take the square root, I get y equals plus or minus 4. So I found 2 points of this parabola. When x is 2, y is 4. And when x is 2, y is negative 4. This is the correct graph of the parabola. It happens that this line that connects 2 points on the parabola going through the vertex, although again, this is not needed. I don't have to graph it, but it has a name. It has a special name. It's called locus rectum. It comes from Latin. Okay? So I did not know how open the parabola would be, or how narrow, how wide or how narrow. What did I do? I said, okay, let's see what happens right here at this point. When x is 2, I replaced x in the original equation. I got y squared equals 16. And now solving for y, I got plus or minus 4. So therefore, the locus rectum is between these 2 points. What points? 2, negative 4 and 2, positive 4. Now the parabola is completely defined. We define the directrix, we have the vertex, we have the focus, and we also have the locus rectum, the points that signify the line that passes through the focus and connects 2 points on the parabola. Now the parabola is fully defined. Any questions on this? Any questions?
How would you write the locus rectum again?
That's how we determine it.
Like, how would you report it?
Oh, it's between, perfect question. Locus rectum is between these 2 points. I will say between 2 comma negative 4 and 2 comma 4. That's all I would say. Nothing else.
Just between the 2 points.
Exactly. Exactly. And it has to be the line passing through the focus of the parabola. Excellent question. Any questions and anything else? Okay, let's go back. Now let's also look at x squared equals negative 4y. So x squared equals negative 4y. Let's look at our table. Since we are defining x squared equals negative 4y, the axis of symmetry is the y-axis. Oh, I forgot to mention here, of course, this is the axis of symmetry. Y equals 0, axis of symmetry of the parabola. So back, good. So x squared equals negative 4y, axis of symmetry is the y-axis, because this is a regular parabola, right? Axis of symmetry is the y-axis, and it opens down. Of course, we knew that, because the leading coefficient here. Okay, so again, the question is asking us to determine the vertex, the focus, the directrix, and then graph the parabola. Okay? Good. So the vertex, I didn't mean to write the equal symbol. It's not how it's a point. Okay. The vertex is the origin. When x is 0, y is 0, obviously. Then the fact that we know the parabola will open downward, the focus will be somewhere here. So then the focus, I already know, will have 0 for x and a negative y value, which will be the same thing with A. So therefore, from here we know that negative 4 will equal, let me just copy the formula. So x squared equals negative 4ay. So this, I should have copied this for you so we look at it. So it's negative 4ay. Okay, so this is the general formula, and that's where we have to determine a. So negative 4 is the same with negative, so negative 4a equals negative 4, but without the negative. So this 4a. So a equals negative 1. So I already know that the focus is right here. If this is 1 unit, on the other side of the vertex, I have to have the directrix, which is now a horizontal line, y equals 1. So I determine the vertex, I determine the focus. Now, on this line, which is y equals 1, I'm sorry, y equals negative 1, I have to determine two values, two ordered pairs left and right. So let me go back to the next page. Which page am I on here? I think I missed something. I guess probably it's 10. Okay, so this time I will say when y equals negative 1, x squared equals negative 4y. When y equals negative 1, x squared equals 4, which means x equals plus or minus 2. So when x is negative 2, y is negative 1. When x is 2, y is negative 1. And the parabola is completely defined. Again, this point, negative 2, negative 1. This point, 2, negative 1. So this is where the locus rectum exists, between this point and this point. This is the axis of symmetry, which is x equals 0, axis of symmetry. The vertex is 0, 0. The focus is 0, negative 1. And the directrix is y equals 1. Again, what does this mean one more time? It means that any point, this point, is found at an equal distance between the focus and the directrix. This is perpendicular to the directrix, and this is the distance between the point and the focus. So these two have to equal each other when the graph is correct. Okay. I know we have just a little bit time left. I just would like to move on to the general situation in which the vertex is no longer at the origin. Okay, so let's look at an example. Let's start with this one, 44. Of course, this is a more sophisticated situation, not that much. X plus 4 squared, because you are allowed to use the formulas. So here is the question. Same thing, everything the same. 39 through 56, and this is 44. Find the vertex, focus, directrix, and graph the equation. So here it is. X plus 4 squared equals 16 times y plus 2. So let's go back to the table. Of course, x can have plus 4 or minus 4. Y can be plus or minus. It doesn't matter. So the form is this. Y minus a number squared equals 4a x minus a number. And this is exactly what we have. So let me just copy that for you here. Sorry, it was x. We have x on the left. Sorry. Okay, here it is. So we have x minus h everything squared equals 4a y minus k. Therefore, the axis of symmetry is parallel to the y-axis, and it opens up. That's all we have here. The parabola opens up. And the axis of symmetry, of course, is parallel to the y-axis. Okay, so now let's discover what we need to discover. So the vertex, like before, let me go back for a second. When we talked about the circle, exactly the same idea. X minus h, y minus k. So the center now, which in our case for the parabola will be the vertex, the center was h comma k. Keeping in mind that these have to be negative. So therefore, we established h and k accordingly. Okay, so then the vertex is -4, comma, x is always first, and comma, -2. That's our first step. So when I start graphing the parabola, -4, -2. So this is the vertex. Therefore, the next step is 4a equals 16. Okay, fine. 4a equals 16 means a equals 4. Okay. Going back for a second. Remember what we just said? That the parabola opens up. Okay. So a equals 4 means I only have 2 units here. I need 2 more. That's where the focus is. Okay, since a equals 4 and this is the vertex, I have to have 4 units between the vertex and the focus. Also, 1, 2, 3, 4. On the other side of the vertex, I have to have the directrix. This distance of 4 units between the vertex and the focus has to equal this distance between the vertex and the directrix. The directrix is a horizontal line. Y equals, what was it? -6. Focus now, definitely x equals -4. But now let's determine the y value. So 2 here plus 2 more. So it's 2. From the beginning, one more time. We established that the vertex is -4, -2. And we plot the vertex. Then we compared 16 to 4a, or if you want, we set them equal to each other, and we got that a equals 4. If a equals 4, it means that from the vertex down to the directrix, I have to have 4 units. And from the vertex up to the focus, I also have to have 4 units. Okay. Now, somewhere on this line, I really shouldn't graph it because I don't want you to think that it's part of the graph. I should be able to find 2 points so I can draw the parabola. Without these 2 points, I don't know how open or how narrow the parabola is. Okay. So, when y is 2, I will replace it in here in the equation to find x. So x plus 4 squared equals 16. when y is 2, because I'm on this line with y equals 2. 2 plus 2 is 4. So I have that x plus 4 squared equals 64. Of course, I will take the square root, and x plus 4 equals plus or minus 8. And x equals negative 4 plus or minus 8. And I have two options, negative 4 minus 8, negative 12, and negative 4 plus 8, which is 4. Therefore, x equals negative 12. So this was negative 4. 5, 6, 7, 8, 9, 10, 11, 12. This is 1 point. And the other one is at x equals 4. 1, 2, 3, 4. And this is the other point. So here is my parabola. And this is the locus rectum. And I will identify this as negative 12, 2, and this as 4, 2. And everything is already defined. The focus, the vertex, the directrix, and the locus rectum. We identified everything. As you've noticed, this is not centered at the origin.